Unit 8 Fractions, Booklet 1, Proportions and Ratios. On the first page, let's read through the vocabulary and become familiar with these words. Numerator, how many things of something? It will be the number at the top of the fraction. It's the number of parts present. Denominator, what kind of something that is. It's the number at the bottom of the fraction. The name of it and the number of parts in the whole. Proportion, measurements of one thing are a dilation scalar of a similar thing. LCD, the least common multiple of a set of fractions denominators. The denominators must be the same to be able to add or subtract fractions. We have different number forms. Proper fractions is if the numerator is smaller than the denominator, then the number is less than 1. Unity fraction. If the numerator is the same as the denominator, then the number is equal to 1. Improper fraction. If the numerator is larger than the denominator, then the number is greater than 1. Mixed number consists of both an integer and a proper fraction. Ratio. Relation between two amounts showing the number of times one value contains or is contained within the other. For example, 6 cats to 18 dogs is written as 1 to 3. We have 6 to 18. Each of them could be divided by 6. Percent for each 100. Example, 0.12 is 12%. 0.09 is 9%. Decimal, the standard form of writing a number. Expanded form, factor multiplicities are written out. So for example, we have 2 to the third power would be 2 times 2 times 2. Exponential form. An exponent is written to express how many times a factor is repeated. Scientific notation. A number written as a ones place followed by a series of decimal places multiplied by 10 raised to a specified power. Alright, find an example when each of these types of number forms have been used. Under each term, write an example of where you have seen this form of number before. So under each term, write an example of where that would be. For example, scientific notation, you might see it in populations. So go ahead and find an example for each. Pause the video and move on once you've found those examples. Solve the proportions by cross multiplying. We have 3/4 equals x over 8. So we'll cross multiply because there's an equal sign in between. So 3 times 8, 24, 4 times x, 4x. From there, you could divide each side by 4. X equals 6. 12 over 30 equals 1 over x. 12x equals 30. Divide each side by 12. and each of those could divide by 2. We have 15 over 6. They can each also divide by 3. 5 over 2 equals x. 2/7 equals x over 20. So we have 40 equals 7x. Divide each side by 7. X equals 40 over 7. We'll leave it like that because there's no numbers that you could divide out of both of those. Numbers you'd like to check is 2, 3, 5, and 7. The next one, we have 2x over 4 equals x plus 1 over 8. We'll still cross multiply. (16x) equals 4 times x plus 1. So we have 16x equals 4x plus 4. We distribute the 4 to each of those two terms. Subtract the 4x. And then we get 12x equals 4. Divide each side by 12. X equals 4 over 12. They each could divide by 4. X equals 1/3. X minus 12 over 2 equals x over 14. We'll cross multiply each side. We have 14 parentheses x minus 12 equals 2x. 14x minus 168 equals 2x. Subtract 2x from each side. 12x equals 168. Divide each side by 12. And then you get x equals 14. So we'll cross multiply. Next one, we have 5x plus 6 equals 25 times x minus 2. Distribute. We get 5x plus 30 equals 25x minus 50. Subtract 5x from each side. Add 50 to each side. 80 equals 20x. Divide each side by 20. And then x equals 4. Alright, let's cross multiply the next one. We have x squared equals 5 times 20, which is 100. To get rid of a square, we're going to square root each side. X equals plus or minus 10. Okay, we'll cross multiply these. 0 equals x plus 1 times x minus 1. 0 equals x squared minus 1. Add 1 to each side. Take the square root. X equals plus or minus 1. Okay, we'll cross multiply this one. So if x squared minus 16 equals x squared, subtract x squared from each side. Negative 16 equals 0. That's false, so there's no solution. Let's go to the next section. Simplify each radical. Remember, the numbers you want to try to factor out are the perfect squares. -1, 4, 9, 25, and 49. For 18, that's not a negative number, so we'll go to the next one. 18 doesn't divide 4 evenly, and so we'll try 9. The square root of 9 times the square root of 2 is equal to the square root of 18. Square root of 9 is 3. 3 square root of 2 is your simplified form. Okay, now we have square root of 12x squared. We want to separate the number and the variables. So for the number, it's just like before. We could take out a square root of 4. 4 times 3 is 12. Now with the variable x squared, we're going to rewrite it using this property right here. It's x to the 2 over 2 power. It's over 2 because the index is 2. And that would give you x to the first power, which is just x. So then you put those together. 2x square root 3. Square root of 150. We could take out 25 out of this. 25 times 6 would give you 150. 5 square root 6 would be your reduced radical. Square root of 98. For this one, you could take out the square root of 49. 49 times 2 is 98. 7 square root 2 would be your simplified radical. We have the cube root of 24x to the 15th. This is a cube root, so we're going to try to take out perfect cubes instead of perfect squares. So we have -1, 8, 27, 125, and 343. It's not negative, and 27, 125, and 343 are too large. So 8's the only possible one we could try. Eight times 3 is 24. So we could write that out right here. We have 2 cube root of 3. And then for the variable, we'll write it out again using the exponent property. We have x to the 15 over 3 power. That's x to the 5th power. So our simplified form is 2x to the 5th cube root of 3. Let's go on to the next page. We have similar triangles. It says ABC is similar to DEF. Let's go ahead and mark these. So we have A and D, and then B and E, and then C and F. So we want to find X. 3 over x equals 4 over 6. You set up your proportion and then you solve it just like on the previous page by cross multiplying. 4x equals 18. Divide each side by 4. They both go into 2. X equals 9 over 2. Let's look at number 2. Triangle GHI is similar to triangle JKL. Let's label these. G goes with J, and then H goes with K, and then I goes with L. It's good to get into the habit of marking each side because the triangles may not always be facing the same way. Okay, we're going to solve for x. 15 over x equals 5 over 4. Cross multiply. 5x equals 60. Divide by 5. X equals 12. Let's look at the next one. Triangle MNO is similar to triangle PQR. So let's mark these. M goes with P. N goes with Q. And O goes with R. Notice on this example, the triangles are not facing the same way. So that's why it's important to mark which sides correspond with each other. Alright, let's set up our proportion. 4 plus x over x minus 2 equals 5 over 2. Cross multiply. We have 5x minus 10 equals 8 plus 2x. Subtract 2x from each side. Add 10 to each side. Divide each side by 3. X equals 6. Number 4, triangle ABC is similar to triangle ADE. Let's mark the sides. So A goes with A. B goes with D. And C goes with E. First, let's solve for y. 12 over y equals 5 over 10. Cross multiply. 120 equals 5y. Divide by 5. Y equals 24. And then now let's use that to find x. We know that x plus 10 equals y. And we know that y is 24. Subtract 10 from each side. X equals 14. On number 5, we have triangle FGH is similar to triangle IGJ. Let's mark these. F goes with I. And then G goes with G. And then H goes with J. If we set up the proportion, we want to find y first. 6 over 5 is equal to 8 over y. 8 is the 6 plus 2. Cross multiply. We get 40 equals 6y. Divide each side by 6. And we get y equals 20 over 3. We know that y equals 5 plus x. So then we have 20 over 3 equals 5 plus x. Subtract 5 from each side. We want to get the same denominator, so we're going to multiply the 5 by 3 over 3. And that'll give you negative 15 over 3 plus 20 over 3. And that gives you 5 over 3. That's x. Okay, on number 6, we have triangle KLM is similar to triangle KNO. Okay, the K goes with itself. And then L goes with N. And then M goes with O. M, and then the whole thing is O. Alright, let's solve for x. 10 over 6 is equal to 30 over x. Cross multiply. 180 equals 10x. Divide by 10. X equals 18. And then to get y, you just have 30 equals 10 plus something. That something is 20. Let's look at number 7. Triangle RSP is similar to triangle QTP. R goes with Q. S goes with T. And then P goes with itself. Alright, let's solve for y. 12 over 10 is equal to y over 5. And the 10 came from adding these two together. Cross multiply. 10y equals 60. Divide by 10. Y equals 6. Now let's figure out what x is. We'll have 12 over x plus 4 is going to equal 6 over x. And this 6 came from the y value. Okay, cross multiply. 6x plus 24 equals 12x. Subtract 6x from each side. 24 equals 6x. Divide by 6 on each side. X equals 4. And let's look at number 8. Triangle STU is similar to triangle VSU. Okay, let's mark these. S goes with V. T goes with S. And then U goes with U. So let's set up our proportion. 18 over x equals x over 2. So these numbers is what was highlighted in yellow, and the top ones were what was green. Let's cross multiply. X squared equals 36. Square root each side. X equals plus or minus 6. We're dealing with lengths, so it's just positive 6. Before moving on, answer this question at the bottom of your page. How is solving proportions useful in real-world contexts? Answer the question in the box provided.